frankly, just exploded in the scientific community. We're talking about 3i Atlas.
It's one of the most compelling things we've ever tracked. For
Yeah.
sure. So our mission today is to get you up to speed on why this object is so strange, what the main theories are, rock versus something else.
Something technological.
Right. And also the unbelievable story of how bureaucracy, of all things, actually tried to get in the way of the science.
It's a huge story, and I think to even start, we have to kind of ground ourselves. We're on one small rock, our view of the universe is still pretty limited.
That's a perfect starting point. We need that cosmic humility. The moment we think we've seen it all, that we have all the models, is the moment we stop discovering things. And 3i Atlas is a real test of that.
Okay, so let's get into the specifics. 3i Atlas. The 3i is important here.
It's huge. It means it's only the third interstellar object we've ever confirmed. First was Oumuamua, then Borisov, and now this one.
And this one is not behaving like the others. Or at least not like a simple comet.
Not at all. It's showing some really significant anomalies. The big one, the headline, is its non-gravitational acceleration.
Let's just break that down for a second. What does that actually mean in simple terms?
It means something is pushing it. The sun's gravity is pulling on it, of course, but there's another force, a constant, gentle push that is making it deviate from the path gravity alone would dictate.
Like a very, very low power engine is running.
That's a great way to think about it.
Yeah.
And with a normal comet, we'd say, okay, that push is from ice turning into gas, creating jets.
Right, and that gas and dust would create a big, obvious tail.
But 3IS doesn't have that traditional dusty tail. And what it does have, well, that's where things get really startling.
This is from the new images taken after it passed the sun around November 11th.
Yes. The post-perihelion images, they show this incredibly complex structure. Not just one jet, but seven. Seven highly collimated jets.
And collimated is the key word there. It means they're focused, like beams, not just a diffuse cloud.
Exactly. And the scale of these things is just mind-boggling. They stretch out for up to 1 million kilometers toward the sun and 3 million kilometers away from it. It's immense.
This all sounds so familiar. It's impossible not to think of Oumuamua.
It takes us right back there. Remember, Oumuamua had that same unexplained push, but with zero visible gas or dust. Absolute none.
So they had to invent a whole new category for it.
They called it a dark comet, which basically admits it's accelerating like a comet, but it looks nothing like one. 3i Atlas is forcing that same conversation, but now with these 7 really structured jets to explain.
Okay, so that sets up the big question. Comet or craft? How do we figure this out?
Well, there are 2 main hypotheses on the table for how you get those jets.
Number 1 is the natural explanation.
Right, the natural origin. This says that sunlight is just hitting pockets of buried ice, causing them to sublimate, to burst out as gas, creating these focused jets.
And hypothesis 2 is the more exciting one.
The artificial origin, that these aren't natural jets at all, but, thrusters, vents on the surface of some kind of technological craft.
The amazing thing here is that this isn't just a philosophical debate. There's a clean scientific way to tell the difference.
A true acid test. And it all comes down to one thing: speed. The speed of the material coming out of those jets.
So if it's natural, like boiling ice, how fast would that material be moving?
Pretty slow in cosmic terms. You're looking at a few hundred meters per second at most. It's a gentle, low-energy process.
But if it's artificial thrusters?
Then it's a whole different ballgame.
Oh.
Even for a low-power engine, you'd expect speeds of at least a few kilometers per second, an order of magnitude faster.
And that's not a subtle difference. That's something we can measure.
Easily. We just need to do spectroscopy and look for the Doppler shift in the light from those jets. It will tell us, unambiguously, how fast that stuff is moving. We should have that data in the coming weeks.
So the data will give us the answer, and yet there's been so much pushback against even, considering the artificial hypothesis.
Well, this is what some people call the arrogance of expertise. It's like, imagine an AI that you've only ever trained on pictures of apples.
If you show it an orange, it's just going to call it a weird apple?
It has to. It doesn't have the category orange in its data set. Some comet experts are the same. Their training data is only natural comets. So when they see something weird, they just try to force it into the comet box.
Even when we have examples of technology that act this way.
Exactly. We have perfect analogs they just ignore. Think about that piece of space debris, 2020 SO, or the Tesla Roadster that SpaceX launched.
Right.
They're both technological objects, and they both show non-gravitational acceleration with no tail. They behave just like dark comets.
Yeah.
So we know technology can do this. Why pretend it's not a possibility?
As if this wasn't high stakes enough, the whole investigation just slammed right into a wall of bureaucracy.
Oh, this part of the story is unbelievable. It really shows how science can get sidetracked by politics. The whole drama is about the high-rise camera.
Which is on the Mars Reconnaissance Orbiter.
Right, so it had this perfect opportunity to get pictures of 3I Tellus when it flew past Mars back in early October. A totally unique side-on view,
High-resolution images, too.
30 kilometers per pixel. I mean, really detailed stuff. But that data, that crucial time-sensitive data, was held for, depending on the source, between 40 and 42 days.
What was the reason? Was it a complex download?
The official reason was the U.S. government shutdown and just bureaucratic red tape. But the really suspicious part is that the HiRise website was still releasing other images of Mars every single day.
So they weren't shut down entirely.
No, they specifically singled out the 3I Tellus images. Their website literally said communications about the interstellar object were suspended because of the shutdown.
It sounds like the object itself was flagged as sensitive.
It seems that way.
Yeah.
And the scientific cost of that delay was huge. Scientists were losing the best window to analyze that unique angle. It was a race against time.
And this bubbled up outside of just academic circles.
It did. People noticed. An official letter went to NASA, and then Congresswoman Anna Paulina Luna made a public statement about it. She said scientific knowledge was being held hostage by politics.
Wow.
It was a perfect and honestly a pretty shocking example of how the system can get in the way of discovery, especially when the topic is a little controversial.
Well, thankfully, the waiting game on Earth is over now.
Right. As of November 11th, the object moved far enough away from the sun in our sky that Earth-based telescopes can get a good look again.
And this is really just the start of a new era, isn't it? The Rubin Observatory is coming online soon.
And that is going to be a game changer. It's expected to find not just one or two more of these, but maybe dozens of new interstellar objects over the next 10 years.
So we need to be ready. We need a plan to check every single one of them.
To see if they're icy rocks, or, as the saying goes, tennis balls thrown by a cosmic neighbor.
And the commitment to do that is now, well, it's formalized. There was an actual wager.
Yes. A public bet was made on November 12th with Michael Shermer from the Skeptic Society. The bet is that by the end of 2030, we'll have undisputable scientific evidence for an extraterrestrial technological artifact.
It shows real confidence in the data-driven approach. And we've already seen this open-minded search pay off with the IM-1 meteor.
Absolutely. That expedition to the Pacific Ocean to retrieve fragments from the first interstellar meteor we ever detected, it was a huge success.
They found those little spherules.
And when they analyzed them, they found a material with a chemical composition we've literally never seen before. It proves that when you go looking for things that are truly new, you find them.
What's amazing to me through all of this is how much it has captured the public's imagination. This isn't just for scientists anymore.
Not even close. There was that great little anecdote about a scientist being recognized by a dishwasher attendant just from his voice on the radio, who then immediately asked for the latest on 3I odds.
My favorite is the 14-year-old girl. Waking up at 4 a.m., so captivated by this, and she asks her dad, "Daddy, is it possible 3I is fueled by antimatter?"
I mean, how great is that?
That's pure scientific curiosity.
It is. It shows this whole thing transcends the usual skepticism. It requires us to be humble and just follow the data wherever it leads. It has to be about the evidence, not about protecting old models.
It brings to mind that advice for young scientists. Stay curious. Don't pretend to be the adult in the room who has all the answers. Life is a learning experience.
Exactly. The data is coming in. Now we just have to be brave enough to analyze it honestly.
Which leaves us with the biggest thought of all. Let's say the measurements come back and they show speeds of kilometers per second. If this object is proven to be artificial, it changes everything.
Everything.
It would mean our most basic ideas about how common technology is in the universe are just wrong. And if we can be that wrong about something flying right through our own backyard, what else are we missing just because we aren't willing to look?
It's time to find out.
And that is our deep dive. We hope you feel fully up to speed on the mystery of 3I ATLS. We'll be back next time.